Hello everyone, this is Hamid Mandal and today we are going to study about the experiment 2. So this is the continuation of experiment 1 and in this experiment we will use the moving wires and derivative filters using ECG and real-time PPG signal. For ECG we will use the recorded signal and for the real-time PPG signal we will record it lively in the Arduino software with the PPG sensor and use that signal. So let's look at the experiments. So the first one, the four experiments are same, just we are doing applying it on the different data. So in the first one, we have to smooth out the high frequency noises. So we will again use the moving average filter. We have declared an input and output array, and n equal n a variable 1000, and L is the length of the block of moving average filter. So this is 8. Now in the void setup, serial dot begin equals to 9600, and in the loop we are recording the first 1000 sample from the sensor, then applying the data processing on it, and again we are recording, and this continues. So at first we have declared a for loop for I equals to 0 to I less than 1000, x of I equals to analog read A0. So our PPG sensor is connected at the analog pin A0, and the other two ports are connected to plus 5 volt and ground. So in between taking two samples, we are giving a delay of 10 milliseconds. So you have to take it into account. So now the normal process applies like what you did in the last lab. We are using two for loops, one for the declaring the y of I and another for the taking the first 8 samples and averaging that and get a single value. So the moving average function and is same as follows. And then for we are printing the data x of I and y of I. So you can see that in the live recorded PPG signal, some high frequency, very much high frequency noises are there in the low portions. So the blue one is the lively recorded PPG signal, and the red one is the smoothen out PPG signal. Now let's look at the second one. Choose a filter to emphasize the high slope portions in the signal. In the last experiment, I have already explained that for this experiment, we have to choose the derivative filter. We can choose the first order derivative or say 3-point central difference derivative filter, any one of our choice. But the second one will work better. So I will I will show you the output. So again, we are doing the same thing, declaring input and output arrays, declaring the length and length of block of moving average filter. Now in the void setup remains same. In the void loop, we are recording the data with a delay of 10 milliseconds. So you can see this as follows. Now next we are applying the moving average filter to smooth out the high frequency noises. Otherwise the output will be very clumsy. So after applying the moving average filter, we are applying the first order derivative filter on that smoothened out signal, and again we are applying the second 3-point center difference filter on the smoothened out signal only, and we will compare both the results. So as you can see, then the blue one is the smoothened PPG signal, the red one is the first order difference, and the green one is the 3-point center difference. So there is not much difference, but as I have shown you in the first lab only that 3-point central difference filter, however emphasizes the high slope, high slope portions much in a much better way. Now in the third one, design and moving average filter with the L equals to floor into 0.8 into n to extract the baseline drift component from a signal. So here we are, as I explained you the baseline drift, that it is the DC of variable DC offset added to the main PPG signal. So we are doing it in the same way, just we are declaring input and output arrays, and we are taking here two moving average filter. One is to smooth out the signal, that is L equals to 8. Another is M equals to 800, that will give me the like DC offset value or the baseline drift. Now while setup remains same. In the void loop, we are first recording the first 1000 samples and with a delay of 10 milliseconds. Then we are applying our first moving average filter, that is to smooth out the high frequency noises in the signal. Then now we get the smoothened out signal. Now we are applying the second moving average filter to get the baseline drift component. Z of I is my baseline drift, and the second moving average filter is applied with M equal like length equals to 800. Now in the third part we are so I got in Y of I got the smoothened out PPG signal with the original PPG and the baseline drift. If we subtract the baseline drift from the smoothened signal, we will get the corrected PPG signal. So we did that, and now we are plotting the data. So see first in the red one is the smoothened out PPG signal. The blue one is the original PPG signal, red one is the smoothened out, and no, sorry. The blue one is the original PPG signal, red one is the corrected and final PPG signal after removing the high frequency component and baseline drift. And as you can see, the increasing baseline drift in that is the green one. So our fourth question is find the output of signal processing system which performs first order derivative filter, then performs MA filter with n equal to 8. So here also the same thing, all remains same up to void setup. In the void loop, we have recorded the first 1000 samples with delay of 10 milliseconds. Then we have applied the derivative filter, as you can see, first order derivative filter, and then we have applied the moving average filter. And after that, we have plotted our data. The blue one is the original PPG signal, red one is the output of the first order difference for the original PPG signal, and green one is the smoothened output of the first order derivative. So you can see that it is very important to remove the high frequency noises before from the original signal before using it or applying feeding it to any other filter. Now, so we have seen the experiments on lively recorded PPG, from the live taking input from the live sensor. Now we will do the same thing but on the recorded ECG signal. We will observe the ECG output. So let's look at the first output, that is where our question was, use moving average filter to smooth out the high frequency noises. So you can see the first one is the ECG with original ECG and the red one is showing the smoothened out or the ECG signal without high frequency noises. Now here you can observe a thing. If we increase if we keep L equals to 8, that is the block size equals to 8 in the moving average filter in this region, then these peaks will get like cut off at some frequency. It will be cut off because this if I get a point here and then a point here, then I am taking the average of all. So I will I won't get this peak. So for getting this peak, we have to reduce the block size, and I have reduced it to L equals to 4. And for all the ECG experiments, I will do it with L equals to 4. So that's the only point here, doing the experiments with ECG signal. Now in the second question, we are told to emphasize the high slope portion. So the first one is the smoothened out ECG signal. Now the red one is the output of the first order difference and green one is the output of the 3-point central difference. And you can see that 3-point central difference is emphasizing the slopes more than the first order difference. In the third one, we are told to remove the baseline drift. So blue one is the original ECG signal, green one is the extracted baseline drift from the given signal, And red one is the final ECG signal after removing the high frequency components and baseline drifts. And in the fourth one, we are told to apply first order difference filter first and then smooth out it using moving average filter. So we have done that. That the blue one is the first original ECG signal, red one is the first order difference filter output, and you can see the high slope portions is emphasized more, but we have to remove that. So we applied moving average filter on the first order difference filter. So we get this smooth and first order derivative filter output. So this is the end of the second lab. If you have any doubt regarding the lab, you can or regarding the code or the parts which I have not explained in this, you can refer to the my first video, and there you can find all the description, what is baseline drift and etc. Thank you.